In this video, I'm picking up where I left off in the prepared statement project. I've created methods to add an artist, add an album, and add a song. Each method takes a prepared statement. I'm not creating the prepared statement in any of these methods because they may be called multiple times. Instead, I'm passing a prepared statement to each method. To execute these, I'll create a method that will loop through the records in my CSV file, determining when each needs to be called and executing them. I'll call this method add data from file, and that'll take an open connection and throw an SQL exception. I'll set a variable for the records in the file, so a list of string. I'll need a try catch because I'll be calling read all lines on the file's class. I'll pass it the path of my file, which is in the working directory, and it's named newalbums.csv. If an IO exception is thrown, I'll throw a runtime exception instead. After this, I'll have a list of records which are comma delimited. I'll set up some local variables next. I'll initialize last album to null, and the same with a variable named last artist. I'll check these variables to determine if a new album or new artist is indicated in the file. The file has grouped the artist. There's only one, Bob Dylan, and it's grouped the two albums' song titles. I'll initialize the artist ID to -1, and the same for album ID. Next, I'll set up a try with resources block, and in the try clause, I'll get prepared statements for each of my insert queries. The first I'll call PS artist. Because I want the generated key back, I can pass the return generated keys to the prepare statement method as a second argument. Next, I've got PS album for the album insert statement, and again I'll pass that constant. The last prepared statement is for the insert song code, and again I want the auto-generated key back. I'll leave the try block empty for the moment. I'll complete the try with a catch clause. Here, I'll call the rollback method on a connection if something throws an error, and I'll propagate the error up, but that's a runtime exception. In the try clause, the first thing I want to do is turn off auto-commit. I do that by passing false to the set auto-commit method on connection. I'll loop through the records I got from the file. I'll split each record into columns using the comma as a delimiter. I only want to insert an artist once, so I'll check if the artist name has changed or if it's null. If either of these conditions was met, then I'll set the last artist to the value in the first column, which is the artist name in my file. I'm assuming here that these are all new artists for simplicity's sake. And I'll execute my method, addArtist, passing it my prepared statement, the connection and the artist name. I'll do the same thing for album name, so it will only get inserted once when the value of last album changes. Album name is in the second column in my file. Then I'll call my addAlbum method, passing the album prepared statement, the connection, the artist ID I got when I called addArtist, and the last album, which should have the value of the new album to be added. This method returns the album ID. Finally, each record represents a song on the album. So I'll call that song for every record, passing the prepared statement for the song SQL, the connection, the album ID I got back from adding the last album, the last two arguments are the track number and song title, which are my third and fourth columns in the CSV file. If all of these statements executed successfully, I'll call commit. Then I'll set auto commit back to true. Finally, I'll just call this last method from the main method. I'll call this method first, passing it the current connection. I want to see the data we get back from the view after the execution of this method, so that's why I put it here before the select code below. I'll update the parameter for the prepared statement I used to select data, making that Bob Dylan instead of Elf. I'll run this code and see what happens. First, I can see a series of statements with IDs printed. These don't include the type, but I can guess by their order. At the start, there's the artist, then the album, then followed by a series of song inserts. You can see the consecutive numbers listed for the song inserts. And after this code runs, you can see all the data from the select from the album view was printed. Even though I'm not using batch processing here, I've still been able to take advantage of the prepared statements precompiled feature. This means the execution of each of these queries should be much faster than if I had just used a statement. but I'm still making a round trip to the database server, so about 30 round trips in this case. Let's add batch processing to this code. Because I need to retrieve the automatically generated artist ID and album ID, I can't batch these statements. But I can batch up the song insert records for a little more efficiency. Before I do this, I'll open up SQL Workbench and change the album and songs tables to allow cascade deletes, and then we'll delete all this data for Bob Dylan before we rerun. So open my SQL Workbench for your dev user. Make sure you have the Schemas tab open in the left panel and highlight albums. Click the tool or wrench icon to the right. Look for a series of tabs below the form. Select the Foreign Keys tab. On this screen, highlight FK Artist ID. This lists the columns and any reference column, so you can see Artist ID does have a reference column. On the furthest right panel, some foreign key options. You can see that on delete, it's set to restrict. I'll change this to cascade from the drop down. I'll select the Apply button. This will display the DDL script that gets run to effect this change. I'll select Apply Next. I should get a message that the SQL script was successfully applied to the database. I'll select Finish and I'll go through the same series of steps for the songs table. So I'll select Songs and click the wrench icon. That pops up a tab and I'll select Foreign Keys again. I'll highlight FK Album ID this time. I'll change the value of the OnDelete option from Restrict to Cascade. I'll again hit the Apply button. I'll hit the next Apply button. And finally the Finish button. To test this, I'll open a Query tab. This is the first icon under the top menu listing. First, let's query the view for Bob Dylan data. Executing this statement with the lightning bolt, I should get the same information my Java code listed in the last execution. Now I'll delete the artist Bob Dylan. If I set my cursor directly before the word delete, I can run just this statement by selecting the lightning bolt icon with an eye over the top of it. You can see at the bottom of the screen, I get error code 1175, you are using safe mode. This is a built-in MySQL Workbench feature that prevents you doing an entire table deletion. It's a useful feature to prevent a potential disaster. You often do not want to delete an entire table's contents. But here, that's exactly what we want to do. I need to go into Preferences and turn off this feature. So I'll click Edit and select Preferences. I'll then click SQL Editor and turn off this safeguard by unchecking the Safe Updates box. Note that it protects both deletes and updates of an entire table, which happens when we do not filtering the SQL statement in some way, as is the case here. I'll click OK. I'll rerun the SQL delete code again, and I get the same error. I'll try refresh, but I think I have to restart MySQL Workbench for this change to take effect. I'll re-execute the select again, just to see if that works. I'm still getting the same error, so I'll close down and restart MySQL Workbench. Right, so let's try the select and delete again. Success, finally. We don't get any errors. Without the cascade delete, I would have gotten errors trying to do this. I'll set my cursor before the select keyword and again click the execute inline icon. This executes the select against the view, and now I have no data. So my single delete statement deleted 2 related albums as well as 27 related songs. I'll jump back to IntelliJ and I'll make some changes to this code to support batching up all the song records. I'll start with the add song method. First, I'll make the return type void and not int. Then I'll remove the first statement where I initialize song ID. I'll remove the entire if statement and all the statements in there. I don't need to get the song IDs for my code, so I'll remove all these. Finally, I'll remove the return statement. Next, I'll remove the execute update method call since we are batching the addition of the songs. I'll execute add batch on the prepared statement. Again, add batch won't execute anything, it just populates a list of statements that will be run when the execute batch method gets called. I'll go back to the add data from file method and scroll down to just before the commit statement I make. Here, I'll be executing all the queued up statements on the PS songs prepared statement. Each statement returns the number of records affected, returned as an int array there. I'll set up an int array variable called inserts and then execute batch. If everything worked perfectly, the insert's length should be the number of records inserted, but it's possible a count could be 0 if something went wrong. I'll create a total inserts variable. I'll set up a mini stream here with arrays.stream, passing it the inserts array, and then terminating with the sum operation. This quickly sums all this data. I'll print this information out, and I'll run this again. My first 3 statements of output are the artist ID and the 2 new album IDs. Then I get the statement that 27 songs were inserted. This was done with 1 trip to the database server. And then I can see from the view the records are all there. Anytime you're executing a series of statements whose only difference is column values, as was the case in this code, you should use a prepared statement. The prepared statement has many advantages over the statement. Precompilation involves parsing, optimizing, and storing the SQL statement in a format that can be efficiently executed by the database server. This process occurs only once, making subsequent executions faster. Parameterized queries are supported with placeholders. These are identified as question marks in the SQL string. They're used for dynamic data values and get replaced with actual values at runtime. These help prevent SQL injection attacks by separating SQL code from user input. Another advantage is efficient reuse. A prepared statement can be used multiple times, executing the same or similar SQL statements with different parameter values. This results in improved performance. With parameterized queries, we get automatic type conversion. This means a prepared statement handles the conversion between Java and SQL data types, ensuring data compatibility. Using prepared statements help with readability and maintainability. Code that uses prepared statements is easier to read and understand than looking at a series of concatenated SQL strings with user input, for example. A prepared statement also provides type safety when binding parameters to SQL statements. This helps avoid data type mismatches that lead to runtime errors or data corruption. With all of that being said, our insert code still has a couple of major flaws because of the very nature of having to execute up to 3 insert statements for a single song in an album. I wasn't able to batch the entire process, so if I had 1,000 new albums and 1,000 new artists, I'd still be doing 2,000 round trips to the database. If a problem occurred inserting the second album, none of the song titles for the first album would have been inserted because of the way I coded this. In the next video, I'll demonstrate how to address some of these problems with something called a stored procedure. You can think of this as a method on the database server we can access. But before I get into that, I've got another challenge for you. So I'll see you in that next video.